Bismillahirrahmanirrahim. We are discussing second year mathematics. Today we will discuss the topic of integration by parts. Integration by parts. What is integration by parts? In previous sections, we have learned some of the basic techniques of integration to solve problems like integral of x square, integral of sine of x. But how do we evaluate an integral whose integrand is the product of the two functions, such as integral of x into sine of x, such as integral of x into e of x, such as integral of x into natural log of x? To solve integral of the type that like that, we have a technique called integration by parts. For the recognition of integration by parts, for this technique, recall the differentiation of the product of the two functions f of x and g of x. So he take the derivative of two functions f of x and g of x. We know that how to use product rule. First function into derivative of second, second function into derivative of first, first function into derivative of second, plus second function into derivative of first. So by rearranging this one, this will become this one, and taking integral on both sides, so this will become like this. So this integral and this derivative cancel each other. So we have only f of x into g of x minus g of x into f prime of x t of x. The equation that can be transformed into more convenient form by substituting u is equal to f of x and v is equal to g of x. So this will become du is equal to f prime f x dx, and dv is equal to this one. So putting the values, we have this formula of integration by parts. Integral of u dv is equal to u into v minus integral of v du. So this is the formula for integration by parts. This is u dot dv minus, so this is equal to u v minus integral of v dot du. So this is our formula for integration by parts. So we have to select one function as u and the other function as dv. So by this one, we have find the values of u, dv and du. Okay, so first example number 10, which is x into e of x d of x. So one function is u and the other function is e of x. So make let u is equal to x and dv is equal to this one, e of x d of x. So we have to select one as u and the other as dv. So the first is u and the second one is dv. So this will become du divided by dx is equal to dx divided by dx, taking derivative with respect to x on both sides. So when we take the integral of this one, so this will become v is equal to e of x, v is equal to e of x. So this will become du divided by dx is equal to 1, which implies that du is equal to dx, du is equal to dx, v is equal to e of x. Simply putting the values, integral of x dot ex dx is equal to u into v. U is x and v is equal to e of x minus integral of v is e of x, and du is equal to d of x. So x into e of x minus integral of e of x is e of x plus c. So this is our final answer. So the second question is, we have this question, integral of under root a square minus x square, this one. So under root a square minus x square dot dx. So we know that the formula of integration by parts is u dv is equal to u into v minus integral of v dot du. So here we have to select one function as u and other function as dv. So this is u and this is dv. Now let u is equal to under root a square minus x square, and dv is equal to this, dv is equal to dx. So taking derivative of this with respect to x, du divided by dx is equal to 1 divided by 2 under root a square minus x square, and this will become minus 2 of x. And when you take integral of this on both sides, so this will become v is equal to x. So v is equal to x, this 2 is cancelled with this 2. So du is equal to minus x dot dx divided by under root a square minus x square, and v is equal to x. Now putting the values in the equation, u is equal to this one, v is equal to this one, integral, and v is equal to x, and du is equal to this one. So putting all these values in the equation, so this is equal to I is equal to, this is equal to I is equal to this one, and this is equal to u into v into v into du. Okay, so this is so this will become by simplifying this one here, we add plus 1a square and minus a square, add and subtract a square on in numerator. So by rearranging this one, so this will become this one. So by splitting this into its fraction, okay, so this one we this one is equal to I, and I plus I is equal to 2I, and the integral of this one is equal to sine inverse of x divided by a. So 2I is equal to this one, so dividing 2 on both sides, so this equation will become this. Now second part is similar to this, this is equal to u and this is equal to dv. Similar, putting the values and adding a square in numerator and finding the integrals of all the term. This question is similar to previous one. So this is equal to u and this is equal to dv, and simplify this one in similar manner. Now we will discuss this question. This is the most important question according to examination point of view. X and natural log of x dot dx. So we know that one is u dot dv is equal to u into v minus integral of v dot du. So rearranging this one, natural log of x dot dx. So u is equal to natural log of x, and v is equal to dv is equal to x dot dx. So du divided by dx is equal to 1 over x, and du is equal to dx divided by x, and integral of this one will become x square divided by 2, v is equal to x square divided by 2. Putting all the values, integral of x dot natural log of x dx is equal to u into v. What is u? U is equal to natural log of x into v. V is equal to x square divided by 2 minus integral of v. V is equal to x square divided by 2, and du. Du is equal to dx divided by x. Dx divided by x. One x is cancelled with this one, and this will become natural log of x divided by 2 dot x square minus 1 divided by 2 as a common, and x dot dx. By simplifying this one, this will become natural log of x dot x square divided by 2 and minus 1 by 2. We know that the integral of x is x square divided by 2 plus c. and this is equal to natural log of x dot x square divided by 2 minus x square divided by 4 plus c. So this is our answer. Now next example is about integration by parts is so this is our next example, e of x and sine of x. Now we will take sine of x as u and sine of x as u and e of x as dv. Now integral of e of x sine of x dot dx. Now let I is equal to integral of e of x dot sine of x dot dx. Now we will take sine of x as u and e of x into dx as dv. Now let u is equal to sine of x and dv is equal to e of x dot dx. So this will become du divided by dx is equal to cos of x, and this will become du is equal to cos of x dot dx. This is our du, and the integral of this one is v is equal to e of x, and putting the values, we know that u dot dv is equal to u dot v minus integral of v dot du. Simply putting the values, integral of e of x sine of x dot dx is equal to, our u is sine of x, our v is e of x minus integral of v is e of x, and our du is cos of x dx. Now we will solve this. So this will become, this is equal to sine of x e of x. Again here we use integration by parts. U is equal to cos of x and dv is equal to e of x dot dx. So du divided by dx is equal to minus sine of x, and v is equal to, taking integral of this one, is equal to ex. So putting the values, sine of x dot e of x minus, and again here we use integration by parts, u into v, u is equal to cos of x and v is equal to e of x minus integral of v e of x, and du is equal to minus sine of x into dx, minus sine of x dot dx. So this will become sine of x dot e of x minus cos of x dot ex. So this will become plus e of x sine of x dx. So this will become sine of x dot e of x minus cos of x dot ex minus e of x sine of x dot dx. Now let this is equal to I. This is equal to I. So I is equal to this one. So here we see that this is also I. This is also I. This and this are similar. So I is equal to, taking ex as common, ex common, sine of x minus cos of x minus, this is equal to I, and this I when come on to the left hand side, this will become plus I is equal to ex sine of x minus cos of x. 2i is equal to e of x sine of x minus cos of x, and I is equal to e of x sine of x minus cos of x divided by 2. So this is our answer. So the integral of e of x sine of x is equal to this one. Now we will discuss questions in the exercise about integration by parts. So this is one important thing about integration by parts. So this is a most important thing about integration by parts. So I have to remember this one. Here is very helpful for an order of priority for which factor the derivative must be passed to. So there is a preference by taking the function as u. We know that one function is u and the other is dv. So when you have inverse trigonometric function, take it as u. When you have only logarithmic functions, take it as u. When you have algebraic functions and no inverse trigonometric function and logarithmic function, take it as u. When you have trigonometric function and not these three functions are present, take it as u. Okay. So when you have all these functions are not present, only this function is present, take it as u. So this is the preference about making one function as u. First of all, make inverse trigonometric function u. When inverse trigonometric function is not present, only logarithmic is present, so make it as u. So when this is present, these two are not, make it as u. When this is present, all these three are not present, make it as u. So make it as u when all these are not present. So we discuss the questions of exercise about integration by parts. We have discussed this question and this question in the previous video. You can find this these two questions in the below link, and here we will solve only this question, question number 3. Evaluate the following by using integration by parts. So question number 3, part number first, we have integral of x square dot e power 2x d of x. So we have the preference, inverse trigonometric, and then we have log functions, then we have algebraic functions, and then we have trigonometric functions, and then we have e power x exponential function. So this is the order. So here we have this, so make it as u, and this is dv. So we know that integral of u dot dv is equal to u into v minus integral of v dot du. So make one function u. Which function u? This function u, because this is not present, this is not present, algebraic function is present, make this u, make this u, make this u. So u is equal to x square, and this is equal to dv, this is equal to dv. dv is equal to e of 2 of x dot dx. Now take derivative of this one, du divided by dx. So derivative of this one is equal to 2x, and integral of this one dv is equal to integral of this one, and take integral of this one. So v is equal to e of 2 of x divided by 2. Okay, so du is equal to 2 of x dx, and v is equal to e of 2x divided by 2. So simply putting the values in the formula. This is our du, this is our v, this is our u. Now we will put the values. Integral of x square dot e of 2x dx is equal to u into v. U is equal to x square, and v is equal to e power 2x divided by 2 minus integral of v. V is equal to e of 2x divided by 2 dot du. Du is equal to 2x dot dx. So this will become x square dot e of 2x divided by 2 minus, so this 2 is cancelled with this 2, so we have x dot e of 2x dx. Okay, So again we use here integration by parts formula. Integration by parts formula. Make one function as u and other function as dv. So u is equal to x and v is equal to e of x dot d of x. So taking derivative of this one, du divided by dx, derivative of x is 1 and integral of this is dv, dv is equal to this one. So integral of this one and integral of this one, v is equal to e of x. So du is equal to dx and v is equal to e of x. We have u, we have du, we have v. Okay, so putting all these values here, so this will become x square dot e of 2x divided by 2 minus u into v, u into v, u into v, u is equal to x and v is equal to e of x minus integral of v, v is e of x dot du, du is equal to 2 of x sorry here this sorry we will put these values, not these values, these are for first this one. Okay, sorry, so we put this value u into v, u into v minus integral of u v e of x dot du is equal to d of x. So this is closed. So x square dot e of 2x divided by 2 minus x dot e of x minus the integral of this one is equal to x. So this will become plus e of x plus c. So this is our answer. Now we will discuss second part of the question, part B of the question. We have to remember this preference of taking one function as a u. Okay, so I can write second part of the question, which is second part of the question is the integral of x cos of x dot dx. So make one function as u and other as dv. We know that integral of u dot dv is equal to uv minus integral of v dot du. So one as, so inverse trigonometric function is not present, logarithmic function is not present, and we know that algebraic function is present. Take algebraic function as u. Now u is equal to x and dv is equal to cos of x dx. So du, taking derivative of this one, du divided by dx, derivative of x is 1 and integral of this one. When we take derivative of sine of x, it will become cos of x. So v is equal to, so derivative integral of this one is sine of x, and this will become du is equal to dx. Now putting the values of u, v and du, so this will become x dot cos of x dx is equal to u into v, u is equal to x and v is equal to sine of x minus integral of v into d of u is d of x, and we know that x sine of x minus the derivative of cos of x is minus sine of x, so this is equal to minus cos of x dot plus c. So this will become x sine of x plus cos of x plus c. So this is our answer. Now third part, Now third and the fourth part are similar, and we have discussed question like this in the examples, but here we solve the question: integral of e of x sine of x dot d of x. Now we know that u integral of dv is equal to u into v minus integral of v dot du. So no inverse trigonometric function, no logarithmic function, no algebraic function, so trigonometric function is present. So take it as u and take ex dx as a dv. Okay, I can rearrange this one. Let I is equal to, I can make it as I is equal to, first I write sine of x because I take it as u, and e of x dot dx later on I write. So let u is equal to sine of x, and dv is equal to this one, e of x dx. Now take derivative of this one, and this will become du divided by dx is equal to cos of x, du is equal to cos of x dot dx, and taking integral of this one on both sides, so this will become v is equal to, we know that integral of e of x is e of x, v is equal to e of x, u is equal to sine of x, and du is equal to this one. Simply put the values, I is equal to I, this is equal to I is equal to u into v, u into v, u is equal to sine of x, and v is equal to e of x minus integral of v, which is e of x dot du, du is equal to cos of x dot d of x. Now here we again use integration by parts. So for integration by parts, no inverse trigonometric function, no logarithmic function, no algebraic function, because trigonometric function is present. So take trigonometric function as u and other as dv. Now I solve this one. So I solve this one here. I solve only this one. This one I solve only and put this one here. So this will become under root of, integral of e of x cos of x dx is equal to so u v minus integral of v dot du. I can rearrange this one. Cos of x ex dx is equal to u v minus v dot du. Now this is equal to u and this is equal to dv. U is equal to cos of x and dv is equal to e of x dx. Taking derivative of this one, du divided by dx is equal to minus sine of x, and this will become du is equal to minus sine of x dot dx, and this will become minus du is equal to du is equal to, only I need du is equal to minus sine of x dot dx. This is the value of du, and taking integral of this one, so by taking integral of this on both sides, so this will become v is equal to e of x. So this is the value of v, this is the value of u, and this is the value of du. Simply put the values, so this will become u into v, u is cos of x, and v is e of x, this e of x minus integral of v, which is ex, and du is equal to minus sine x dot dx, minus sine x dot dx, minus this one bracket. Okay, so this will become cos of x dot ex plus e of x sine of x integral minus sign, I here this minus sign multiply this, so this will become plus dx. So here we know that e of x sine of x is equal to I. sine of x into e of x is equal to I. Sine of x into e of x is equal to I. So this is equal to cos of x dot ex plus I. So here put the values of this one. So this will become I is equal to sine of x dot ex minus, so this will become cos of x dot e of x plus I bracket. So I can write it here. So I is equal to sine of x dot e of x minus cos of x dot e of x minus I. So this I comes here, so this will become plus 2i. 2i is equal to e of x common, sine of x minus cos of x. So I is equal to e of x sine of x minus cos of x divided by 2. So this is our answer. The integral of e of x sine of x d of x is equal to this one. Now the next part is similar to this one. Now I will solve part E of the question. Part E of the question is, this part is similar to this one. Okay, so I am solving this part. So we have the preference for taking the function as u. First is inverse trigonometric. Okay, so the second is log. So the third is algebraic, and the next is trigonometric, and the last one is exponential. Okay, so we have the question integral of sine inverse of x. Integral of sine inverse of x. Now we will solve this question, integral of sine of x. Integral of e part, integral of sine inverse of x dot dx. Now inverse trigonometric function, present inverse trigonometric function, so take it as u and take it as dv. We know that u dot dv is equal to u into v minus v dot du. So we have to select one as u and other as dv. So u is equal to sine inverse of x and dv is equal to dx. Now take the integral of this one. So this v is equal to x, and take derivative of this one. Du divided by dx is equal to, so the derivative of this one is, I check what is the derivative of sine inverse of x. Sine inverse of x is equal to 1 divided by under root 1 minus x, under root 1 minus x square. So this is the derivative of this one. So this will become, so this is equal to du is equal to dx divided by 1 minus x square. So we have u, we have v, we have du. So putting the values, integral of sine inverse of x dx is equal to u into v, u into v. U is equal to sine inverse of x dot v. V is equal to x minus integral of v. V is equal to x dot, and this is equal to this is equal to du is equal to dx divided by 1 minus x square. Now this is equal to sine x dot sine inverse of x minus, so this will become 1 minus x square. So the under root power is 1 by 2, so when this become up, so this is equal to minus 1 by 2 into x dot dx. So this is equal to x dot sine inverse of x minus, and this is equal to 1 minus x square minus 1 by 2. I can write minus 2 here. I multiply with minus 2, and here I divide with minus 2. I divide with 1 over minus 2. I multiply with minus 2 and divide with minus 2. So this is equal to x sine inverse of x minus. So here this minus I write outside, this is plus 1 divided by 2 integral of 1 minus x square minus 1 by 2 minus 2 of x dot dx. Now we know that the formula is, what is the formula? Integral of f of x whole power n, and here you have f prime of x dx. So this is equal to f of x whole power n plus 1 divided by n plus 1. So this is f of x whole power n. So when you take the derivative of this one, this derivative of this one 0, and this is equal to minus 2x. Minus 2x is present. So applying this formula, so this will become, is equal to x sine inverse of x plus 1 by 2. So this is equal to f of x 1 minus x square f of x n plus 1 and minus 1 by 2 plus 1. So by solving this one, you will get sine inverse of x plus 1 by 2. So by solving this one, you will get 1 minus x square 1 by 2, and here also 1 and 2 here. So this 2 is cancelled with this 2. So this is equal to x sine inverse of x plus, so this is equal to under root 1 minus x square. Okay, so this is the integral of sine inverse of x. Now we will discuss last part of the question. I discuss last question. Last part of the question is e of x f part. So e of 3t sine of e 3t dot d of t. Now I can write it as before solving this by integration by parts, we have to select it. We have to select let x is equal to e power 3t. Okay, so dx divided by dt is equal to e power 3t into 3. So this will become dx is equal to e power 3t dot 3 and dt. So this is equal to x, this is equal to x. So dx is equal to x 3 dt. So dx divided by dx divided by x we will we can also solve it as direct by using integration by parts formula in order to avoid the confusion. So make it as sine of e power 3t dot e of 3t dt. One function is u and the other function is dv. So make sine of e3t, make sine of we know that u dot dv is equal to uv integral of v dot du. So one this make u is equal to sine of e 3t and dv is equal to this one e 3t dot dt. So differentiate this with respect to t, because here this is t not x. Okay, du divided by dt is equal to this is equal to sine cos of e 3t dot 3. Okay, so this will become du is equal to cos of e 3t dot 3 dot dt. This is the value of du. Okay, now dv is equal to this one, dv is equal to e power 3t dot dt, integral of this one taking on both sides. Okay, so this will become v is equal to e power 3t divided by 3. So this is our v, this is our u, this is our du. Okay, so make it as, let this is equal to I. So I is equal to u into v. U is equal to this one, u is equal to this one, sine of e 3t, u is equal to this one into v, v is equal to this one, e power 3t divided by 3 minus integral of v, v is equal to e power 3t divided by 3, and du is equal to cos of e 3t dot 3 dt. So this 3 is cancelled with this 3. So I is equal to 1 over 3 sine of e power 3t dot e of 3t minus I write first cos of e power 3t dot e of 3t dt. Now I solve this by integration by parts formula, and put the value of this here. Okay, so this is equal to cos of e power 3t dot e of 3t dot dt, make u is equal to cos of e3t, and dv is equal to e of 3t dot dt. Take derivative of this with respect to t, not x. Okay, du divided by dt is equal to minus sine of e3t dot 3, and taking integral of this one, so this will become v is equal to e of 3t divided by 3. So this will become du is equal to minus 3 sine of e3t divided by dt. So this is value of du, and this is value of v, and this is value of u. So this is equal to under root integral of cos of e3t dot dt is equal to u into v, cos of e3t u into v, e3t divided by 3 minus integral of v e3t divided by 3 dot minus 3 sine of e3t dot dt. So this will become e of 3t divided by 3 dot cos of e3t, this 3 is cancelled with this one, this minus this one, plus e of 3t dot sine of e3t dot dt. So this is equal to I. So this is equal to I. Here we have, so this is equal to I. This is the question, our question. Here you see that this is our question. Okay, so this is our question. I is equal to this one. Okay, so e of 3t sine of e3t is equal to I. So this is our question. So put this is equal to I. This is equal to I. So this is equal to e of 3t divided by 3 cos of e3t, this plus I. Okay, put the value here. So this, put the value here. Okay, so this is equal to, so this is equal to, so this is equal to I is equal to 1 divided by 3 sine of e3t dot e3t minus, put the value of this one is equal to this one, e of 3t cos of e3t divided by 3 plus I, and this will become I is equal to 1 divided by 3 e3t sine of e3t minus e of 3t divided by 3 cos of e3t minus I. So this I, when the become on this side, this will become plus 2I, and 2I is equal to 1 over 3 common, 1 over 3 e of 3t common. So this will become sine of e3t minus cos of e3t. This is equal to I is equal to, this will become 6 e of 3t divided by 6 into sine of e3t minus cos of e3t. So this is our final answer, plus C. So this is our final answer. In this way you solve question by using integration by parts formula. In the next video, inshallah, we will discuss our next exercise.